Good morning, class.
Good morning.
How's everybody doing?
Good.
Good. How was yours weekend? Did you guys have a good time?
Yes, I had a good time.
Oh, awesome. What did you guys do?
I spent time with my baby cousins.
Oh, really? Baby cousins. Okay. Did you guys do anything in particular?
We colored. I made
Colored?
pumpkins.
Oh, that sounds fun. Well, I had a great time too, myself. I had an awesome weekend. Well, do we remember what we learned last week?
Yes.
What was the topic about?
2D shapes.
2D shapes. Awesome. What did we say 2D shapes were?
Two-dimensional shapes.
Two-dimensional shapes. Okay, great. Two-dimensional shapes. And what else do we find, or what else do we talk about two-dimensional shapes?
We found their areas and we also drew them.
We found the surface areas and we also drew them. Outstanding. Okay, well, today we are going to talk about what? 3D shapes. 3D shapes. If we're able to talk about 2D shapes, what do you think? Give me like an educated guess. What do you think three-dimensional shapes are? Or what do you think it will be? Three-dimensional shapes.
A shape that has more sides than a two-dimensional shape.
Awesome. A shape that has more sides than a two-dimensional shapes. Yeah. 3D shapes basically it just I would say an upgrade of a 3D shape. Okay. So of a 2D shape. Sorry. And 3D shapes usually they have the length. They have the width. And of course, they had what? The depth. So if in 3D shapes, find the surface area, we're going to be looking at things like the length, the width, and then the depth, okay? So in 3D shapes too, we find the surface areas and the volume. I forgot to tell you. We also find the volumes of 3D shapes, okay? So somebody will ask you, well, so how do we find 3D shapes, like surface areas and volumes of 3D shapes? Well, I have a formula chart that you don't have to memorize. I'll give it to you in a minute, okay? But before I do, give me some examples of 3D shapes. Yes, Kate?
How about a cone?
A cone, yes, a cone is a 3D shape. So let's draw a cone in a 3D shape, okay? This is a cone in the 3D shapes. Can you give me another example of what a 3D shape looks like?
A cylinder.
A cylinder, great job, a cylinder. A cylinder can be in 3D shape as well. You see that? Okay, great. Well, I also have more examples. For example, we have the sphere. The sphere, we all know what a sphere looks like, right? Could be a 3D shape. We have the prism. We also have the pyramid. Like for example, this. See, this could be a prism. Okay. These are the shapes. We have more shapes. For example, we have the cuboid. We have the prism. We have the pyramid. Okay. All right, so now 3D shapes. We have formulas that we use when it comes to 3D shapes. Like I said, I'll give you the formulas in a minute. You don't need to memorize them. Next week, I'll show you how and why we have those formulas that we do. Okay, so now let's talk about surface areas. Surface areas about the cone and the cylinder. The cone and the cylinder. Okay, so based on well, before I do, let me pass you the formula charts. Okay, and then that one also. All right, so now look at the formula chart. Can you tell me what the surface area of a cylinder will be? The surface area of a cylinder. What do you think the surface area of a cylinder will be? Yes?
2 pi r times r plus h.
2 pi r times h. Good job. 2 pi r. Well, yeah, 2 pi r plus h, all into bracket. Yes, great job. Where r is what? The radius. The h is going to be the height. And of course, the pi. The pi should give you a value in there. What does it say?
3.14.
3.14. Great job. 3.14. We did a great job. Don't forget that, okay? All right, now let's talk about the cylinder. What do you think the surface area for the cylinder? What does it say in the formula? Well, it should be at the bottom of it. You know, it should be at
Pi r times r plus 1.
pi r times r plus 1. Okay, is that what it says? Pi r, who else? Does anybody has any? Okay, let's see what we can. All right, I made a small arrow. I was actually asking for the surface area for the cylinder, and then I said cone, okay? So the surface area for the cone will be, the surface area for the cone is what? Yes?
For the cone, is it 4 pi r2?
Not quite right, but good try. Look down the formula chart. It's supposed to say something like pi something. Yes?
Is it pi r times r plus 1?
Great job. It's pi r plus 1. Okay? Be very careful. And also, once again, our pi is going to be 3.14. The r always stands for the radius, and the 1, of course, is a constant. All right, so now, without much ado, we're gonna solve some problems about finding the volumes and the surface areas of some 3D shapes, okay? All right, so problem number 1. Problem number 1. It says calculate the volume of a cylinder shown. Calculate the volume of the cylinder shown. And the shape of our cylinder is going to be this. And it says the radius here, which is our r, is going to be 4 centimeters. And then the height is going to be 6 centimeters. All right, so the volume, based on the formula chart, what does it say? What is the formula for the volume based on the formula chart? Yes.
Pi times r squared times h.
Great job. Pi times r squared times h. And that is going to be our volume. So our pi is always what?
3.14.
3.14, great job. Times the r, our radius, which is what?
4.
4 what? 4 centimeters, right? So times 4 squared times the h, our h is what?
6.
6, good job. So 3.14 times 4 squared, which is going to give you 16, times 6 will give you a total volume of what?
$301.5928947
Good job. So we can just easily write it as 302 centimeters cubed. Any question? Anybody? Do we agree why we got 302 centimeters cubed?
Yes.
Good job, good job. Okay, well, let's try a second problem, okay? Problem number 2. This time we are going to talk about the cone, finding the surface area of the cone or finding the volume of the cone. So, problem number 2, it says a triangle with width 3 centimeters, 4 centimeters, and 5 centimeters is rotated the side of 3 centimeters to form a cone. The volume of the cone is formed as, so basically find the volume of the cone, okay? So we have our drawing or a figure to be like this, okay? We have our height to be 4 centimeters. And then we have our radius to be 3 centimeters. So therefore, finding the volume is going to be what? Look down that formula chart and tell me what the volume or the formula for finding the volume of a cone will be. Yes.
I think it equals 1/3 r squared h.
1/3 r squared h. Yes, 1/3 r squared h. What did I say the r stands for?
Radius,
What about the h?
the height.
Great job. Okay, so without much ado, and all right, so finding the volume. So we have 1/3. Our radius is gonna be what? 3 cubed times the height, which is 4. If you multiply 1/3 by 3 cubed by 4, it is going to give us what? A total of what? You're gonna get 12 pi centimeters cubed. Of course, we know what pi stands for, right? 3.14. Okay, great job. All right, so that will be, we're gonna leave it here for today. We're not gonna go into depth about it. We'll tackle it another time. But before I do though, good job for today. Good job for today's contribution. That was very outstanding. We did talk about 3D. That 3D is, we did talk about 3D, that 3D is three-dimensional shapes that are different from two-dimensional shapes by the sizes and the height and everything and the width, okay? So, and then also we talked about the volumes and finding the surface areas of what 3D shapes. Okay, now let's tie this into real world problem. Let's try into real world problem. What are some of the things, well, based on what we learned, what are some of the things outside that you can relate, shapes outside that can relate our topic today too? Yes?
Well, a cube could be like an ice cube.
Great job. A cube could be like an ice cube. Awesome, awesome. Anybody else? Yes?
What about those orange cones in the road, like the safety cones?
Oh, great job. Safety cones, good thinking. Safety cones, that's amazing. Yes, the little orange ones. Yes, that's great, that's great. All right, well, next week, good job on that. Next week, guess what we're gonna be doing? We're gonna pick up on what we left up today, all right? We're gonna discuss about the three-dimensional figures. We'll talk about the use of it and how to build different types of 3Ds, okay? All right, so anybody has any question, anything they wanna add, they wanna subtract, anything? Based on what we talked about, the lengthy lectures I just gave you, does anybody have anything to say? Any questions? Okay, great. That means we understood it. But should you have any problem today or about the problems, the homework I'm about to give you, please let me know. Do not hesitate, okay?
Okay.
All right, good job, good job.